For this problem, we have if a p-n junction is doped with a boron at a concentration of 6.7 times 10 to the 16th centimeters cubed, this is per centimeters cubed, and phosphorus at a concentration of 9.4 times 10 to the 17th centimeters cubed, what is our built-in voltage in millivolts? So we're going to find it in millivolts for our junction. We're going to assume that our Ni is equal to 1.5 times 10 to the 10th cubic meters, and this is per cubic meters, and Vt is equal to Kt over Q, which is equal to 26 millivolts at 300 K. Since small changes in the built-in voltage imply large changes in our doping levels, be sure to give our answers in the millivolts. So we're going to be solving for millivolts, and we're going to be using the equation that we have to the right in the notes linked below the like button here. So we have our PN junction built-in voltage, and this is the formula we're going to be using. We want to find our voltage output, so we're going to be looking for V out. And with our V out, we need to find our VT. And we know VT is equal to KT over Q. Well, our VT is also given to us right here. So we have VT is equal to KT over Q, and this is equal to 26 millivolts at 300 K. So this is equal to 26 times 10 to the negative cubed, because that is our millivolts right there. Next, we're going to have our Ln. So inside of here, we are going to have Ln, and then inside of here, we have some things at top and some things on bottom. We have our Na and our Nd. And so with this, we can look back and we can find out what our Na and Nd is. But for here, we can just note that our Na is going to be the 6.7 times 10 to the 16th per centimeters cubed. And this is being multiplied by our 9.4 times 10 to the 17th. And this is per centimeters cubed. And this is all over our Ni, which is going to be squared. So we'll have this here. And our Ni we know to be 1.5 times 10 per centimeters cubed. And this is going to be all squared. And so we can see that our per centimeters cubed are going to cancel out because this is going to be squared down here. So if we plug this into a calculator, like how I have here, we have our 26 10 cubed, our Ln, of all of this inside of here, and we're going to get approximately 0.86490. But we want this in millivolts, so our answer is going to be 864.90. So that's our answer in millivolts for our PN junction.